Connecting your devices on the edge is all well and good, but there are some pretty critical mistakes that orgs keep making that render their AI projects dead in the water. Hey there, my name is Christopher Sandoval. I'm a developer relations advocate here at FlowFuse, and today we're going to highlight 5 reasons that AI projects fail at the edge. Poor data context. Here's a simple fact that orgs seem to not get. Raw data is not usable information. Industrial systems generate a ton of signals, but those signals are useless without context. And the simple fact is that AI needs as much context as possible to be truly effective. For instance, imagine you have a sensor, and the data that this thing is generating is tagged with names like machine 1 or temp. While that might make sense to you, the operator, what does that actually mean? For the machine, how does it know what the unit of temperature is? It might be able to know that this is machine 1, but machine 1 of how many? And why are there no timestamps to provide context for when this data was even generated? And even worse, is this sampling sporadic? Is it meant to happen once a second? All of that context is missing, and that context is incredibly important for AI to actually work and to work well. At best, your AI output is going to be confusing, and at worst, it'll be completely useless. The solution here is to provide context right when the data is being generated. Plan it as if you're sending this data to someone with no familiarity of your system. You want it to be so structured that someone, whether it's a person or a machine, can get up to speed as fast as possible. Prototype architectures in production. So AI is a frontier technology, but that doesn't mean that your implementation of it has to look like an experiment. Artificial intelligence in the last couple of years has grown from something that may have value to something that demonstrably has value. But for a lot of orgs, they're still stuck in this experimental mindset. And a lot of projects, especially those that interface at the edge, are treated like they're still experimental. This can take a lot of different forms. You may have isolated notebooks running Python code instead of remotely controlled deployable pipelines. You might have hard-coded credentials instead of environment variables. You could have poor or no lifecycle management. No matter the symptom, you still have the same core issue. You're treating your production system like it's a prototype. In order for industrial environments to integrate cleanly with AI, they have to be predictable. They have to be stable infrastructure that's here for the long term. And that means that they can't be built like they're temporary infrastructural solutions. So when working with edge devices, you have to make sure that you're building for the long term, and you're building for something that is deployable, that's maintainable, scalable, and extensible, and not just a stopgap to implement AI today. To solve this problem, after you have proven your initial experiments, implement your AI systems as if you were integrating a brand new team rather than just buying a software license. That'll make sure that your experiments don't fail catastrophically and that your final deployment will be a successful one. Treating systems integrations as an afterthought. Industrial AI has to connect to a lot of different systems. And this is especially true in infrastructure that has a lot of edge connectivity. We're not just talking about PLCs. Sometimes you can have a mixture of connectivity solutions even on the same device. You might have a device that's pushing out to MQTT and OPC UA and SCADA. You might have legacy hardware that only speaks one particular protocol. And while all of these systems are working, they not only have to interface with systems downstream, they also need to integrate with systems in a way that makes sense and maps to the overall architectural choice. In other words, you need to make sure that your edge devices are actually aligned to your IT and OT structures. And when it comes to building AI into these systems, all of that is doubled. You need to actually understand how you're going to map your AI securely into these systems. Do they get a user role? Do they get a tool role? Are they treated like another PLC, or are they treated like a remixer node? Does the agent that you develop mostly work in the OT or IT space? And do they have access to the tools in those spaces to do what they need to do? And there's even more fundamental questions like, how are we going to give this thing authorization and authentication? If we use tokens, how long are those tokens going to be valid for before we revoke them? All of these attributes have to be figured out in any system. But in an agentic system where the lines of ownership and processing are already super blurry, this becomes even more important. It's tempting to think of AI software as something that you can just plug, play, and forget. But the result of an effective AI system is kind of like onboarding a new team member rather than just buying a license to a piece of software. To be clear, there's no clear answer here, but the solution is actually knowing you have to ask this question. It's not good enough to just build the AI, give it an endpoint, and then say, well, everything's perfect. You have to actually think about how you're going to implement the solution at scale. You have to figure out these critical parts in order to make sure that your infrastructure, as well as your AI, actually want to work together and have the tools to do that. To solve this problem, you need to treat your systems like agentic workers and not just pieces of software. Consider how you might secure, integrate, manage, and log the activities of a team, and apply that to all of your AI interactions throughout the entire stack. Treating the edge like it's not the edge. Look, there's a huge gulf of difference between an edge environment and a cloud environment. When you hear that, you might say, well, duh, right? The reason this is an important point to understand is that a lot of people don't understand the core differences between the edge and the cloud. They think about the edge as just being like the cloud, but a little bit more limited. The fact is that there's a litany of issues with the edge that the cloud doesn't have to care about. You might say something like, oh, well, the edge has local processor and storage restrictions. Well, the cloud has something like that too, right? We don't want to have to pay a bunch of money to cloud computation or cloud storage. So that seems like a one-to-one, right? The edge is always there, whether you're directly connected to it at all times or not. It's still generating data. It's still creating things that you need to know about. Depending on your situation, you might get sporadic updates, or you might get a flood of updates all at once. You might be able to predict this traffic, and you might be able to not predict that traffic. And then there's other environmental variables that you have to care about. The cloud lives in the cloud, and those systems are often so distributed that in most cases, you're never really going to notice a hiccup. But you might have local edge devices in something like a metal foundry, and that's going to be affected by electromagnetic patterns. So when you're doing production, you might have data reliability drop to the floor. And when you're not doing production, all of a sudden, all of your edge devices might connect perfectly. It's those sort of things that we take for granted in edge compute. But when AI is involved, those problems are only exacerbated. AI needs a constant flood of data to really give you valuable insights and inference. But if you're not setting up your AI system to actually work with all those variables at the edge, you're setting yourself up for failure. You need to keep in mind that the edge has very specific problems. Things like network segmentation, the need for store and forward, electromagnetic interference with data transit, distributed local compute for complex processing, and sometimes even security considerations for local data that absolutely cannot leave the network. If you're going to be deploying AI at the edge, you need to understand and treat it as if it's an edge technology. So plan for the edge by building in worst-case scenario provisions for things like store and forward, network failover, security, and segmentation. Also ensure that you're going through active documentation and that you're looking at every single part of your edge network to understand the specific limitations of the network itself. Unclear operational ownership. So I have a question for you. If your model generates an output, who owns it? If it was invoked by an operator, is that data owned by the operator or is it owned by the model? Well, the model was built by the IT team, so does the IT team own that data? If the model goes haywire, who's the person who's fixing it? If the inference is inaccurate, who has to actually go in and rectify and reconcile that data? In many plants, it's unclear who actually owns this process. And that unclear ownership really makes AI situationally and organizationally hard to implement. For edge systems especially, this problem, like all the other problems we mentioned on this list, get even worse. If you're getting inference from something downstream but it's coming up to the business logistics level, well then I would say that the manager needs to own that particular process. But the process of generating that data is being managed by someone entirely separate from the inference itself. Or in some cases, the action might be separate from the inference, which might be separated from the data that's being pushed to the inference. You can start to see that this becomes really complicated, and if you don't think it through, you could get yourself into a hole really quickly. Organizational misalignment and lack of ownership can lead to failure of any kind of project of any kind of size. The solution is to clearly integrate your systems and document clear lines of ownership. Treat your AI systems like you would a PLC or an industrial computer at the edge, integrate fully to gain full control and visibility, and make sure that everyone knows exactly what part of the core system they actually own. The core problem. Ultimately, almost every edge AI project that fails has the same problem at its core. You can't just tack on AI to your industrial systems and expect it to work. And when you have the edge involved, you can double that sentiment. If you just try and tack on AI to the edge without solving the operational, organizational, technical, and ownership problems, you're basically ensuring that your project is going to fail. And this is where FlowFuse is very valuable. See, FlowFuse dissolves the IT-OT divide by providing world-class enterprise tooling. And that means you can get all of the benefits of its AI and MCP integrations without the headaches you run into with typical approaches. Using FlowFuse, you can get clear DevOps pipelines which allow you to version control and dynamically roll out new AI projects faster and more securely than ever. You get clean integration between IT and OT domain concerns, which allow you to roll out a secure system with features like role-based access control and single sign-on, while remaining flexible enough to morph and adapt to new edge technologies and approaches on the fly. You get powerful workflow management that allows you to connect almost anything to pretty much everything, supporting legacy protocols and devices while enabling cutting-edge system integration across the entire stack. And finally, you get world-class AI integrations that give you a powerful edge and tool for flow creation, data routing, local and cloud inference, and much more, at the edge, on-prem, or in the cloud. By leveraging FlowFuse across your entire stack, but specifically with AI at the edge, you make a system that is truly powerful, scalable, extensible, observable, and dependable. We hope you found this video helpful. If you did, please consider giving us a like, comment, or subscribe. For more information on how FlowFuse empowers AI at the edge, check out the links in the description below to look through our documentation and see some awesome use cases. And if this video piqued your interest for FlowFuse, head on over to flowfuse.com to start your free 14-day trial. This has been Christopher Sandwell. Thanks for watching, and I'll see you next time.